Hello students, this is lesson U6A06a. By the end of the lesson, you should be able to say I can solve for lengths of chords, secants, and tangents. Let's take a look. Here are the concepts, the theorems, which you will need in order to be successful in completing the exercises that accompany this lesson. Let's take a close look at what these theorems are saying. So in the past couple lessons, we've looked at how to find angle measures that are formed by chords and secants and tangents. Now what we are going to be focusing on in this lesson is how are we going to be able to find the lengths of chords, secants, and tangents. So to help us understand or to better organize our thoughts, I've placed the various scenarios into four different categories. Okay, the first of which is, well, what is the relationship between the lengths of tangents and secants? So let's take a close look at this. Upon inspection here, let's try to digest what this is saying. That the overall, the portion of the secant line that extends outside of the circle multiplied by the overall length of the secant line will therefore equal to the length of the tangent line squared. That's what the formula there is saying. So again, the portion of the segment that's outside of the circle multiplied by the total length of the secant line will equal to the square of the tangent. Let's move on to the next. Here, when two tangents meet outside of a circle, the two tangents will be of equal length. So both segments that meet outside of the circle will be of the same length. Next, what is the chord relationship if the two chords were to intersect with one another? Well, it just so happens that if I have one portion of one secant line multiplied by the second portion of the same secant line, the proportion holds true, where one portion of the other secant line multiplied by the second portion of the secant line, that product will be equal to one another. So again, a portion of the same secant line, the product of the portions of the same secant line, will equal to the product of the other secant line. Portions of the other secant line, I should say. All right, so, and then the last scenario here, well, if you look at this, okay, we can have a secant intersecting with a tangent, two tangents, and then the last scenario here is what happens if there are two secants? Well, it actually follows a very similar pattern, okay, where we have portion of the secant line multiplied by the overall will equal to, I'll use another color, will equal to the portion outside of the circle multiplied by the overall length of the secant line. So the products of these again will be the same. So these are the four main concepts that we are going to be using. Another really important concept, and this turns up all the time, is a tangent line will always form a 90-degree angle with the radius or diameter. But this was also covered in the previous lesson. So here is everything once again. All right, so let's take a look at our first example. Pause the video here to see if you can apply the concepts that were displayed in the previous slide. Hopefully you guys had some time to think about this, so let's talk about it now. So what we have to do is explain if BD is a tangent to circle A. We know that AD is equal to 20, DC is equal to 9, and BC is equal to 21. Well, in order for this to be a tangent, then what should happen is there should be a right angle here. Well, how do we know if there's a right angle? Well, it just so happens that if AD is 20, AB therefore also has to equal to 20. So therefore, I have a triangle here, but we don't know whether or not this triangle is indeed a right triangle. If this is indeed a right triangle, then it should fulfill the Pythagorean theorem. Let's see if it does. So in order for this to fulfill the Pythagorean theorem, then this relationship must hold true. 20 squared plus 21 squared, will that in fact equal to 29 squared? So 20 squared, that's 400. I don't know what 21 squared is, so I'm just going to jump to my calculator here. So 21 squared plus 20 squared, that will give me 841, and let's see if it does equal to 29 squared. And it certainly does. So because of this, yes, this checks out. They will equal to one another. So we can say BC is tangent to circle A. All right, pause the video to see if you can figure this out. So here again, we need to explain whether or not IJ is a tangent or not. So again, very similar concept. The HK here is 3 because I know that HI is 3, and because HI and HK are the radius of the circle, they have to be of the same length. So will this be of this? Will this hold true? Will this hold true then? 3 squared plus 4 squared, does that equal to 6 squared? And as a matter of fact, it does not, because 9 plus 16 is not the same as 36. So IJ is not tangent to circle H. This is a really similar problem, okay? QS is tangent to circle P. QS is 15, RS is equal to 9. What we have to do is find out what the length of the radius is. So it's a little backwards, okay, in the thought process. Pause the video to see if you can handle this. All right, so hopefully you guys had some time to think about this. So the one unknown in this problem is we don't know what the radius is. But what we do know is that QS is tangent to circle P. Well, in order for that to be true, then again, this has to fulfill the Pythagorean theorem. So R squared plus 15 squared should equal to R plus 9 squared. Don't be afraid of this. This is just the same process. We approach this in the same way. In order for us to figure out what the right-hand side of this equation is, we got to FOIL. R plus 9, when FOILed, will turn into R squared plus 18R plus 81. The left-hand side here is R squared plus 15 squared. 15 squared is 225. Notice now that R squares cancel, because I have both R squares on both sides. So I'm left with 225 is equal to 18R plus 81. What I'm going to do now is I'm going to subtract both sides by 81 and divide by 18. So 225 minus 81, and then I'm going to divide both sides by 18. I'm going to be left with R is equal to this. And what number does that come out to? 225 minus 81 divided by 18 comes out to 8. So R turns out to equal 8. Okay, very similar setup. Pause the video to see if you can tackle this. So I have xy is tangent to circle W. WZ is equal to 7. ZY is equal to 18. We need to find the length of XY. All right, so very similar process. Notice now here we're told that XY is tangent, so therefore this length here must be 7. because that has to be the radius, and this is going to form that 90 degree. This is just a regular Pythagorean theorem again. So I know that xy, quantity squared, plus 7 squared will equal to 25 squared. 25 squared, that's 625. 7 squared is 49. And all I got to do now is isolate xy squared. So I'm just going to go over here to my calculator, subtract both sides by 49. Whoops. 625 minus 49. And then we're going to take the square root. And that comes out to 24. So again, xy turns out to equal to 24. All right. Now we're getting to the meat and potatoes of the lesson. So here, okay, upon inspection here, I noticed that I have a secant and I have a tangent line. I have secant line ABC and I have tangent line DC. So what we have to do is we have to find the length of DC. Pause the video to see if you can apply this. So hopefully you guys had a little chance to, had some chance to figure this out on your own. We know that DC here is a tangent, and that's what we're trying to find. Let's call that length there x. And I have AB is 5 and BC is equal to 2. Well, last I checked, okay, the formula was we take the portion of the secant line that's outside, multiply it by the overall secant line, and that should equal to the tangent line quantity squared. Whoops. That should equal to the tangent line quantity squared. So what can we do then to figure this out? Well, that's just x squared is equal to 2 times 5. Actually, no, 2 times 7. Right? Where did I get 7? Because it's 5 plus 2. So x squared will equal to 14, or x is equal to square root of 14, and that cannot be reduced any further. Okay, let's take a look at the next one. AB is equal to 12. EB is equal to 8. We need to find the length of the radius for circle D. Pause the video to see if you can figure this out. So hopefully you guys had some time to think about this. We know that AB is equal to 12. EB is equal to 8. And we need to find the length of the radius for circle D. So actually, this is the same problem as one of the first questions that we looked at in this lesson. Well, I know that AB is 12, so therefore BC must be 12 because all tangents equal to the same length. However, because these are tangent, I also know that the radius is going to be perpendicular to the tangent. I don't know what the radius is, so let's call that R. So therefore DE must also be R. So this is what's going to happen is I know that triangle ADB is going to form, it's going to be a right triangle. So therefore I can say R squared, which is segment AD, plus 12 squared, which is the tangent, should equal to R plus 8 quantity squared. And it's the same process. So we FOIL the right side, we end up with R squared. So I'm actually going to write this out. Maybe perhaps some of you guys are wondering how I'm able to do this really quickly. So we have R plus 8, R plus 8. So this turns into R squared plus 8R plus 8R plus 64. Or R squared plus 16R plus 64. The left-hand side turns into R squared plus 144. Notice that we have R squares on both sides. So this turns into 144 is equal to 16R plus 64. Let's subtract both sides by 64. So if we do that, we'll end up with 80 is equal to 16R. And if 80 is equal to 16r, let's divide both sides by 16. R will therefore equal to 5.